Hello, this is video 73. This video is going to be short and sweet, talking about buoyant force. It's going to be a very quick introduction because we're going to see this topic in the next 5 to 6 videos. So what is buoyant force? You've probably been in some kind of water at the beach, in a pool, and you feel different when you're in water. Do you feel heavier or lighter? Hopefully you said that you feel lighter when you're in water. This is why, for example, pregnant people, it's recommended that they do water exercises because they don't feel all of their extra weight when they're in the water. They feel a lot lighter. So buoyant force is the net upward force that you feel when you are in a fluid. We're mostly going to be talking about being inside a liquid, specifically water. So what happens if you're in a liquid, or if this object is in a liquid here, that there is a difference in pressure between the top part of the object and the bottom part of the object. You know that the deeper that you go down, the more pressure there is. That's what this arrow is showing, increasing pressure going down. Increasing pressure means more force. The force is acting in all directions here. The liquid pushes inward on this object. We don't care about the side pressures, side forces, because they cancel each other out. But at the bottom here, we're going to have a bigger upward force than we have a downward force, because the pressure at the bottom is bigger. So if you look at these two forces acting on the object, if you have a bigger force pushing up than the force pushing down, that means that the net force will be upward. And that net force is what we call the buoyant force. Let's talk about this in one more slide here. I talked about how you feel lighter when you're in water. Well, how is this related to the buoyant force? So I have this picture here that is showing us that when an object is weighed in air, that's the regular weight, there's a certain reading here. You see that the spring here stretched this much, that indicates the force. And then when you weigh that same object in a liquid, now the force is a lot smaller, the weight is smaller. So this spring scale is measuring your apparent weight. You know that your weight doesn't change, right? We don't all magically get lighter when we go in water. We feel lighter, but we're still the same weight. So the scale measures the apparent weight, your weight when you're in air, or your weight when you're in water. So how is this related to the buoyant force? We just learned that when you're in water, such as this rock here, that it's going to experience an upward buoyant force. Any object in liquid always experiences this buoyant force. This object also has a weight pulling it down. When the object is not in water, that tension here, which is the weight that the scale is reading, so you can call this tension is actually the W1 here, but I'll also call it WA for the apparent weight. Whatever the scale is reading is the apparent weight. The scale reading is balancing the regular weight, the mg. However, when you're in the water, the buoyant force, some of it is balancing part of the weight here. So the scale doesn't have to balance as much, because you can see that the T plus the W plus the B have to balance out the W, the weight. So the T is not going to have to balance as much weight as it did when the object was not submerged. So that's why the T, when your object is submerged, your apparent weight is going to be less than when you are not submerged. If you look at the free body diagram here, and you realize that this object is in equilibrium, you can sum up the forces B plus T going up minus the weight going down. All of those forces must sum up to 0. And if you solve for t, which we said was the apparent weight, it's going to be the regular weight W minus B. And that's exactly what I have written down in this equation here. Your apparent weight when you're submerged, when you're completely in the water, is equal to your regular weight minus the buoyant force. So this explains why you feel lighter when you're in the water, because that buoyant force is balancing some of your weights. So that apparent weight is going to be less.